Welcome to P-eduKUL digital platform. Now we will start the next chapter, that is application of derivatives of part 1. अब तक मुझे लगता होगा कि आप लोगों ने पहले वाले वीडियोस देख के आपको पता चल चुका होगा कि how we are dealing with the chapters. I speak about only the theoretical part, which is quite important for the concepts. So let's see what we mean by the meaning of a derivative. So y is equal to fx be a continuous function of x, and then it represents in the xy plane. Okay, xy plane means the regular Cartesian system, which we use it for to plot the graphs. So these derivatives are actually useful in different kinds of branches, that is engineering and then physics. And then if you say the real life changes, it's nothing but the rate of change. Okay, everything it changes, but then how, at what extent it is changing, that we are measuring from the this derivative, that is dy by dx. So y is a function which should be differentiable, and here what we have written, y is equal to fx is a continuous function. So here what we have done, we have taken the one continuous function and then we have plotted the graph of this, which is a curve. Now on this curve you can see that there are 2 points, P is a point and Q is another point. So P will have the coordinates A, right, and F of A. Means what? The P we will take it any point in X, because function will be in X, and from that you will be getting the value of Y, right? For example, suppose your Y is equal to, suppose your y is equal to 2x. So your P point will be, your x is suppose say 1, then 1 comma 2. Got it? And now my another point, a plus h. So suppose x is equal to 4. Then what I will get it? F of a plus h. F of a plus h, that I will get it 4 comma 4 to the 8. So these 2 points I will get it, and then I will be writing these 2 points. So I will be writing these points. Now this point will be 4 comma 8 and this will be 1 comma 2. I will show you. If this is my function, then this will be 1 comma 2 and this will be 4 comma 8. So this is what I have explained with this particular function. Now this graph is not of this function, it is a general graph. Right, it is a general graph, but when you take any particular function which is differentiable and a continuous function, you will get such kind of points wherein you will be plotting the graph. Specifically, if you speak about, then the what you can say, the quadratic polynomials, if you plot the graph for the quadratic polynomial, you will get the freehand curve which is called as a parabola. Okay, parabola inverted upward and then downward. 2 kinds of parabola you get it from the graph of the quadratic polynomial. Now here they have written in general. So in general what they are saying, if P is equal to A and F of A, Q is equal to A plus H and F of A plus H. Now here when we say A and A plus H, there is a small change in this. Got it? Because of this small change, our function changes. And that is what? At what extent it can be changed? And that is nothing but the slope of the chord. So here, if we take the difference between f of a plus h minus f of a upon fa, that is the slope of the chord PP. So this is the chord we have drawn, which you can see here. The chord is drawn like this, and the slope is calculated by this formula. And this slope is nothing but the derivative of that function, that is dy by dx. Okay, so let the point Q move along the curve such that Q to P, then the secant PQ approaches the tangent at P as h tends to 0. So in grade 10 you have seen the definition of tangent. It is nothing but if this is my curve and this is the line. Tangent we have learned in the case of circle, correct? So circle, this will be the arc. If suppose this is a circle, this part will be called as arc of that. Here we are considering this arc as a graph of any function, and this is the line segment joining this, that is called as tangent. This is called as tangent. So for the curve, if we have drawn the line that is a tangent, Okay, so that tangent we are considering at h is equal to 0. Let's see the further part of it. You will understand more easily. So limit of q tends to q, that is the slope of secant pq, is equal to limit of h tends to 0, f of a plus h minus f of a upon h. Now, while learning the derivatives of first order, we have seen this formula. Correct? This is nothing but the first order derivative. Here it is mentioned. So the slope of tangent at P is nothing but f dash a. Okay? Instead of x, we are saying a here because a is a value on x-axis. We have considered the value on x-axis, and therefore the slope of tangent at P is equal to f dash a. If the limit exists, this is very important part. So the derivative of a function y is equal to fx at any point p of a by b is the slope of the tangent at the point p of a and b on the curve. So derivative is nothing but the slope of the tangent. This simply you can remember this, and that is what here it is written. F dash a is equal to dy by dx at p. P is a point which is mentioned on the curve. Like we write x is any point on the line. Similarly here P is any point on the curve. Now a normal is a line perpendicular to tangent passing through the point of tangency. Point of tangency means point of contact. Okay, and therefore the slope of the normal will be minus 1 upon f dash a. That is reciprocal. See here, the slope of the normal is negative reciprocal of slope of tangent. Once again I repeat, slope of normal is negative reciprocal of slope of tangent. Slope of tangent is dy by dx and its negative reciprocal is slope of normal. Okay, because why these concepts are important? Because in certain questions you know only the slope of tangent, but we need to find out the equation of normal. So in that case you need to find out the slope of normal also, and this formula is very important in that particular case. Okay, so this you have to remember. Now the next is the equation of tangent is nothing but y minus b is equal to f dash a into x minus a. Now this I just wanted to correlate with the equation y minus y1 is equal to m into x minus x1. Now x and y will be the general points, okay, and y1 and x1 these will be the specific points on that particular curve, which here we are saying that a comma b as it is given. P is a comma b, that is the point given, and then f dash a is nothing but the slope. Okay, f dash a is nothing but the slope, which is nothing but dy by dx. Is that clear? So now the equation of normal to the curve y is equal to fx at p of ab is given by y minus b is equal to minus 1 upon f dash a into x minus a. Right? So let's see the examples. Examples will give you the clear idea about the concept. Now what is the question? Find the equation of tangent. Find the equation of tangent and normal to the curve at the given points on it, and the equation is given like this at 1 and 3. Means the point is given 1, 3. So first we will find out the derivative which will give us the slope of tangent. So let's write that. Differentiate with respect to x. So you will get it dy by dx is equal to, now 3 as it is, x square का derivative 2x, x का derivative 1, 1 का derivative 0. So you will get this as 6x minus 1, right? So now this we will calculate at this particular point. Therefore, dy by dx at 1, 3, that will be 6 into 1 minus 1. So this will be 5. So now as I said, dy by dx is equal to what? Slope of the tangent. So that I'll write it here. Slope of tangent will be 5. Now I will write the equation. Point is already given. So now what I told you the formula for the equation. y minus y1 is equal to m into x minus x1, where x1, y1 are nothing but this 1, 3, and m is nothing but the slope, which is 5. So you will get the equation as y minus y1 will be 3 here. Just see, x1 is 1 and y1 is 3. So these values are put into this. So y minus 3 is equal to 5 into x minus 1. So I'll get the equation as y is equal to 5x minus 5 plus 3. So I'll get the equation as y is equal to 5x minus 2. That's it. Y is equal to 5x minus 2. Now this is my equation of tangent. Now I'll find out slope of normal, which is negative reciprocal. So that will be 1 upon 5. And then similarly I'll calculate the equation for the normal. So equation of normal, y minus y1 slope into x minus x1. So this slope I will write it as m1. Okay. So this will be y minus 3 minus 1 upon 5 into x minus 1. After solving this, we will get the equation as x plus 5y minus 16 is equal to 0. So this is your equation of normal and this is your equation of tangent. That's it. Let's see the second equation. Find the equation of tangent and normal to the curve at the given points on it. So this is the equation of, this is the given equation. This is the point. Okay. So from the equation, first we will calculate dy by dx. So first I will calculate the derivative. So this 2 into 2x plus 3 into 2y into dy by dx is equal to 0. So now this will be dy by dx is equal to minus 4x upon 6y. Okay. So this will be minus 2 by 3 x upon y. This is my derivative. Now this I have to calculate at this particular point. So I will be calculating that dy by dx at point 1, 1. Means what I will do, I will put the value as x is 1, y is 1. And then I will get the slope is 2 by 3. So I will write it here. Slope of tangent is minus 2 by 3, and slope of normal will be reciprocal of this, negative reciprocal. So slope of normal will be negative. So negative will become positive, and slope of normal we will get it 3 by 2. Okay. Now we will write the equations of this. So equation of tangent, y minus 1 minus 2 by 3 x minus 1. So if I multiply this, 3y minus 3 is equal to minus 2x plus 2. So I'll get the equation as 2x plus 3y minus 5 is equal to 0. Now the next is equation of normal. Equation of normal will be again y minus y1, slope is 3 by 2, x minus x1. So 2y minus 2, 3x minus 3. So this will be minus 3x plus 2y plus 1 is equal to 0. That's it. So these are the two equations of tangent and normal. Now the next is again the same. Find the equation of the tangent and normal to the curve at the given points on it. So this is the equation of curve. Are you getting it? Which we have to consider, which is intersecting at point 1 and 1. And then we have to find out the equation of tangent and equation of normal to this. So first we will find out the slope of an equation. once you get the slope of equation, you can get that is the slope of tangent. So by reciprocating it, negative reciprocating it, you will get a slope of normal, and then you will find the equations by using the slope point form. This y minus y1 is equal to m into x minus x1 is a slope point form. Okay, so now we will do that, differentiating with respect to x. So what I will get it here, 2x 2y divided by dx, x into y का derivative divided by dx plus y into 1 is equal to 0. So here I will get it 2x plus 1 into bracket, then I will take dy by dx common, then I will get 2y plus x is equal to 0, and hence I will get it dy by dx is equal to minus into bracket 2x plus 1 divided by 2y plus x. Okay, 2x plus 1 divided by 2y plus x, and now I'll be putting the values of as 1 into this. So my slope will be minus 3 upon 2, 3 upon 3. So that is minus 1. This is the slope of tangent, right? Slope of tangent is minus 1. Then slope of normal will be negative reciprocal. So this becomes positive. So slope of normal will be 1. And now we will find out the equation. So that is y minus 1 minus 1 into x minus 1. So y minus 1 minus x plus 1. So this will give you x plus y minus 2 is equal to 0. Now I will find out equation of normal. Plus 1 into x minus 1. So minus 1 x minus 1. So this is the equation of normal, minus x plus y is equal to 0. Or you can write x minus y is equal to 0. That is also correct. Instead of this, you can write x minus y is equal to 0. That is also fine. But it's a standard form, so you can write it that way also. So let's do the second question of this. I hope you remember, all of you remember the formula for differentiation. Then only you will be able to do this. Otherwise, it becomes a bit difficult for to do. So just revise the formula for derivatives. Okay. You also can learn accountancy, economics, SP and OC on P-eduKUL digital platform. And we have a great feature that we will be solving your doubts with the live sessions. So please be connected with us on email and phone numbers. So let's see the next question. Find the equation of tangent and normal to the curve where the tangent is parallel to this line. Now, whenever such kind of a question comes, people get little bit what I can say, they may confuse or something like that. But it's not. You can do the question very nicely. Let us do that. So we will write first. Let P1 x1 be the point. P x1 y1 be the point on the curve x square plus 5 is equal to y, where this is the line is tangent, where the tangent is parallel to this line. Okay. So now differentiating this with respect to x, we will get the slope of tangent. Two x is equal to divided by dx. So now I will calculate this at x1 y1. So I will get it 2x1 is equal to divided by dx. Now this is my slope 1. m1 is equal to 2x1. Now I will calculate the slope of this thing. this will be m2 is equal to what? Minus a by b. So 4 upon minus 1. So this will be plus 4. So this is my another slope. Correct? And therefore tangent, therefore the equation will be what? 4x minus y plus 1 is equal to 0. And the slopes are equal. m1 is equal to m2. So from that what I will get it? 2x1 is equal to 4. So I'll get it x1 is equal to 4. Okay. Now this x1, x2 lies on this particular curve, right? So I will put the value in the equation. Put x1 is equal to 2 in this x1 square plus 5 is equal to y1. So this 4 plus 5 is equal to y1. Therefore y1 I will get it as 9. 4 plus 5 is 9. And then my point becomes 2, 9. And then from this I will get the equation y minus y1 is equal to x minus x1. So this will get it as y minus 9 x minus x1 into m. So this will be 4 into this x minus 2. So solving this I will get it 4x minus y plus 1 is equal to 0. 4x minus y plus 1 is equal to 0. This is my first equation. Now my another slope m2 will be negative reciprocal. So that will be minus 1 by 4. And then the point is 2, 9. So my another equation will be what? Y minus 2 is equal to minus 1 by 4 into x minus 9. And then by solving, I will get the equation as x plus 4y minus 38 is equal to 0. This equation I will get it from this. See, it's very simple logic. First you need to calculate the derivative. Derivative is nothing but the slope of the tangent. If you take a reciprocal of it, you will get the slope of normal. And then you need to find out the points over here. Now, what is given? You see the tangent is parallel to the line. So obviously the slopes will be equal. That is why I have equated both the slopes and then I get the points. Once you get the point, you know already the slopes. One slope if you know, another you can directly calculate by taking just reciprocal of it. And this is how you can do the question. Now the third question again we will do it. It is of same kind. Find the equation of tangent. Just see what all things are given. We have to find out the equation of tangent and normal. Okay, for that we need what? Slope of tangent, slope of normal, and the point. So now here nothing is given. To the curve is given where the tangent is parallel to the line. So from this we can calculate the slopes and then we can solve it. So let's do that. So again I will let the point Px1 y1 be the point of curve. Be the point of curve. Now just I'll calculate the derivative of this. So y is equal to 3x square minus 3x minus 5. So dy by dx will be what? 6x minus 3. Correct? So now I will get this point at x1 y1. So my slope will be 6x1 minus 3. Correct? And then I will calculate the slope of the line. This slope. Slope of line minus b by a. So that is minus 1 upon 3. So this will be 1 by 3. Sorry, a by b. Okay, slope of the line will be minus 3 upon -1. So this will be plus 3. Correct? Now I will equate this. 6x1 minus 3 is equal to 3. So 6x1 is equal to 6. x1 I will get it as 1. So if you get x1 is 1, you can get it y1 also. Here I am supposed to put the values. So that will be 3x1 square minus 3 into x1 minus 5. So this is 3 minus 8, which will be minus 5. So my point will be now 1 comma minus 5. Right? And slope both are same. Both are the same slope. So my equation will be equation of tangent will be y minus y1 m into x minus x1. So y minus 1 is equal to slope is 3 x minus x1. x1 is again 1. So here y minus 5. So this should be 5. So y plus 5 is equal to 3x. Here it is minus 1. So y plus 5 is equal to 3x minus 3. And hence you will get the equation as 3x minus y minus 8 is equal to 0. So this is my equation of tangent. Now a slope of normal will be minus 1 by 3, and just putting the value in the similarly, I'll get the equation as equation of normal. I'll get it x plus 3y plus 14 is equal to 0. After solving this, again similarly with this, just we have to put the slope of normal as minus 1 by 3. So this is how we have completed exercise 4.1. Meet with us on P-eduKUL platform for the other subjects like economics, SP, OC and maths of course. Thank you.